Hey, everybody. Happy Monday. Welcome back. Hopefully, you had a good weekend. I was thinking about the number of the day, and I still haven't actually counted the days, mostly because I'm not sure exactly what the end of the year is going to look like for us. If we'll still continue to have Wednesdays off, if I should count Wednesdays, how far into June are they going to make us go, and stuff like that. So until I know for sure, I'll just have to go without number of the day, but I would guess that when we finally do see number of the day come back, it's going to be a surprisingly low number. Anyway, we're going to pick up today looking at volumes. Your homework assignment tonight is going to look very similar to what the homework assignment looked like the last couple of nights because it will be the same shapes, but now instead of finding what the net looks like or finding the surface area or the lateral area, you're going to be taking a look at the volume. And I've got a whole bunch of these. Don't worry, you don't have to copy down all these formulas. Um, this right angle triangular prism, that's nothing that we're going to worry about in this class. But I just wanted to show you a couple different cool shapes that we can think about with volume. When I say volume, I'm not covering something. It isn't the amount of paper that it requires to cover a surface. When I say volume, I'm talking about the amount of water that it would take to fill it up, or the amount, the size of all the foam peanuts that would fill up a swimming pool, or something like that. To calculate the volume, you're going to figure out how many of these unit cubes fit inside of an object. Just like when we do area, we're finding how many unit squares fit inside of an object. Here we've got these three-dimensional unit cubes. And so for this blue one over here on the left side, if I want to count all of these, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And I know that some of you are yelling at your computer screens right now saying, why didn't you just multiply? I've got 5 rows and 5 columns of these cubes, 5 times 5. This section of it, this part of the prism, has 25 cubes. And I'm going to be smarter about the next layer. The next layer back here must be the same thing. I've got 25 cubes in this layer. I've got 25 cubes in this layer. I've got 25 cubes in this layer. They're all the same thing. That's why our formula for the volume of a prism is going to work the way it does. I'm going to find the area of one of the bases, and then I'll multiply by the number of those layers are between the bases. So if I wanted to do this pink one, I'm going to say that the area of this base is 6 by 4. So this is 24 unit squares along the base. But then I've got 1, 2, 3, 4, 5 layers. So 6 times 4 gives us 24. And then 24 times 5, that gives us a total of, I believe that's 120. If I counted them, there would be 120 unit cubes. And then this shape over here, I've got 3 layers this way, I've got 6 layers this way, and then 3 more layers that way. So 3 times 6 is 18, and then times 3 again. Let's see, 18 times 3 must be 54, 54 unit cubes in this shape. Now, if I have a rectangular prism, we just kind of figured out what that formula is. Length times width times height. Um, However you look at it, length times width times height. Length times width times height. One dimension times another dimension times the other dimension. That gives you the volume of a rectangular prism. Nice, easy formula, but it doesn't work for all of them. My formula for all prisms is going to go like this. If I think about a triangular prism or another rectangular prism, I'm going to think about what is the area of that base? What is the, well, either area or volume of that one little thin layer? And if I can figure out what that is, then I'll multiply by whatever that distance is. So if one layer has a width of 1 centimeter, and I find that this is, let's see, if that's 1, then maybe this is about 7 centimeters. I'll find the area of the base and multiply by the height. I'll find the area of the base and multiply by the height. And that's the formula. The area of the base and multiply by the height. My formula for the volume of a prism, I've said this before, base times height, but before it was the base of a triangle, the base of a parallelogram. Now, because it's the base, it's the area of the base. I'm going to use a capital B to stand for that base, just so we don't get it confused with, you know, maybe the base of this triangle. I use a lowercase b because that's this length, but then this b, that's the area of the whole base. So lots of information going on here, but that's my formula, whether it's a triangular prism, rectangular prism, a square prism, or even a trapezoidal prism, as we're looking at right here. But my formula just says that the volume will be equal to the area of the base. You've had to do this on number 12 on yesterday's assignment, finding the area of that base. You've got to figure out the area of that trapezoid. So my volume in this case, the area of the base, and this is one of those things that we learned about a long time ago, the area of the base of a trapezoid. I'm going to have the sum of the two bases. There's that word again. I'm using it in the lowercase b version because these are the bases, the lengths of the sides of the trapezoid. This one is 10 centimeters wide. This 2 centimeters is actually referring to this length right here. To find this length, I'm going to have to look at a different part on the diagram. This length right here, that's the 4 centimeters. So that's the other base of this trapezoid. So in my formula for the area of a trapezoid, the sum of my bases, base 1 plus base 2, is 10 plus 4. Then we take the sum of the bases and multiply by the height of the trapezoid. That was that 2 centimeters. And then we divided that by 2. So base 1 plus base 2 times the height divided by 2. There is the area of the trapezoid. That's this part of my volume formula, area of the base times the height. And the height of the prism is this 7. The distance between the top base and the bottom base is 7 centimeters. And so once I get done with this whole thing, I will multiply it by 7. So 10 times 4 is 14. 14 times 2 divided by 2, we're still at 14. And then 14 times 7 is 98. And all of my measurements were in centimeters. So this must be 98 centimeters cubed because we're doing a volume. We've got a three-dimensional measurement. Remember, this is the number of those little unit cubes that would fit inside of this shape. So I've got a cubic unit. I've got a length times a length times a length to give me centimeters cubed. So there we go. That's the volume of a trapezoidal prism. But the formula is the same for all of these prisms. The only other one we need to talk about today is a cylinder, because the base of a cylinder is a circle. We're going to come back to this Diet Coke can from the other day. The area of the base, it's still the same formula. Volume is still equal to the area of the base times the height. But because a cylinder has a base that we have a formula for, I'm going to say that the volume of a cylinder is, well, area of the base is pi r squared. And then the height, well, that's the height of the prism. So for the can that we're looking at here, pi is pi. The diameter of the circle is 6. That means the radius is 3. So we'll have pi times 3 squared. That's the area that we actually did in Friday's lesson. And then multiply by the height. The height of the can was 12 centimeters. So I will multiply this by 12. And so we'll have 108 pi if I want an exact answer. I don't know if an exact answer makes a whole lot of sense on this one, but if I asked for an exact answer, that's what I would be looking for. If I want the approximation, I'll plug that into my calculator, 108 times pi, and that gives me about 339 0.29, or maybe I should just round that to 0.3. Remember when I measured this can last week, these were approximate measurements. This wasn't exactly 12. I think it was a little bit less than 12, and it wasn't exactly 6. I think it was a little bit more than 6. So this is not the most accurate measurement. I wonder how far away from the actual volume of a can of soda we got. But I'll leave that to you. Go ahead, grab a can of soda, take a look. This one says 222 milliliters. That's because this one must be a smaller can. It one must be one of those mini cans. But a milliliter is the same thing as a cubic centimeter. So, well, I wonder how far we are. Go ahead, tell your parents that you're going to go grab a can of Coke just because it's in the name of mathematics. But there we go. That's all we need to take a look at today. You should be able to go through and do the next assignment. I will be eventually publishing an answer key for the previous 3 assignments because they're all from the same question. So I'm going to wait and publish those all at the same time, probably later this week. So in the meantime, if you have any questions before I publish that answer key, let me know. Shoot me an email, pop into the Google Hangout, or find some other way to get in touch with me. Otherwise, I will see you next time I see you. Have a great day. Bye.